An incredibly useful feature of Kinetic Model Builder is the ability to summarize the model's behavior across entire families of stimulus conditions. So consider, for example, a very simple model that transitions between resting and active states with the activating transition depending on the concentration of some drug. Now we have a simple protocol, which is a series of pulses of drug with various concentrations. When we simulate this model, we'll just use the eigensolver method. And now we'll look at the states in that simulation. We see now a family of responses where the red curves are the probability to be in the active state and the blue curves are the probability to be in the resting state. And we can step through the various drug pulses, or we can visualize them all at once. And as the drug pulse concentration increases, we see an increasing probability to be in the active state. So let's say we'd like to summarize this model's response to this series of pulses by plotting the maximal probability to be active versus the drug concentration. To do that, we go to our protocol window, bring up our parameters, and go to the Summaries tab, and add a summary. We give it a name. It can be whatever we want. We'll call it P active, reflecting the probability to be in the active state. So we'd like to plot the maximal activity in the active state versus the drug concentration during the pulse that's applied. So for our Y value, we'll call this max active. In this case, the active word has to match the name of something in our model. It can be the name of any model state or state group, or the name of a special signal such as current or gating current or user. For the X expression, we'd like to indicate the value of our drug pulse. So we could simply do max drug, which would give us the maximal concentration of the drug pulse during the simulation. Now, the time windows for which these protocols, for which these expressions should be evaluated are given here by the start and duration for the X and Y signals. So for X, let's just set this to start at 0.3 seconds and have a duration of 0.4 seconds. And we chose that because that matches the start and duration of our drug pulse as defined in our stimuli. And we'll just do the same for our Y expression as well. So now we've restricted our expressions to being during the drug pulse. Because the drug is constant, we could easily as well define this instead of max as mean, although we have to be careful to restrict ourselves now to only during the drug pulse. So this summary will now plot the maximum active probability in the active state versus the mean drug concentration as computed over the time period starting at 0.3 for a duration of 0.4 seconds. We have a couple other options for normalizing the summary, which I'll not describe now. Please see the user's guide for more info on that. Okay, so let's go ahead and run our simulation again. And we've now computed our summary. To visualize it, let's generate a new plot. I will set the line widths and symbol sizes. And instead of viewing our states, I'll turn those off on the left axis, or our stimuli on the right, I'll turn those off as well. We'll instead, on the left axis, visualize our summary. And here it is. So we're now plotting our maximum active probability, which is varying from approximately 0.5 to about 0.9. And that matches about what we see here, 0.5 to 0.9. Well, it should match exactly. Versus our mean drug concentration during the pulse. So essentially, simply the drug concentration of this pulse, which ranges from 1 up to 10. And this sort of summary can be obtained for essentially anything you want. The equations that we specify here can list any named stimulus or again named state, state group, or special model signals like current, gating current, and user. And they can include any sort of standard mathematical operators, as well as mean, max, and min. Um, and the program that is used to parse these equations is EigenLab, which is available on GitHub. And please see the user's guide for more information. All right, that is how to generate a stimulus versus response summary in Kinetic Model Builder. And just as a side note, these sorts of summaries can be used for model optimization, just the same as all of the signals simulated here. See the Optimizing a Model tutorial for more info on that. Thank you much.